We often believe we know the story of our planet, its history neatly arranged in a progression from stone tools to space travel, all within the brief time frame we call history. But what if this story is wrong? What if, long before the pyramids, long before writing, and long before civilization as we understand it, Earth was home to an advanced society, one that rose, thrived, and then vanished so completely that no trace remains? How would we even know such a society ever existed? And more importantly, what would it mean for us today? This is the question no one thinks to ask. In the world we live in, history feels like a straight line. You open a textbook, and the story begins with simple hunters and gatherers, progresses to villages, then kingdoms, and finally modern nations. It all makes sense on paper. A clean timeline suggests that human civilization only began a few thousand years ago. But sometimes the most seemingly logical stories are the most misleading. If you stop and think about it, that timeline isn't based on knowing everything that's ever happened. It's built on the little evidence we've found and how far back that evidence stretches. Here's the question most people never think to ask. What if that timeline is missing something immense? Not just a forgotten empire or a lost city, but an entire chapter of human or even non-human history. One so old, so buried in time, that it occurred long before the date we think civilization began. Could Earth have once hosted an advanced society 100,000 years ago? At first glance, the idea sounds impossible. We imagine that people from that distant past were barely surviving, using rudimentary stone tools, hunting animals, and living in small isolated groups. But this image is shaped by the evidence we've gathered so far. The truth is, the further back you go, the less there is to find. Over 100,000 years, wind, rain, ice, earthquakes, and shifting lands erase almost everything. Even today, the things we build, skyscrapers, cars, bridges, wouldn't last anywhere near that long without constant maintenance. Imagine that our civilization ended tomorrow, and 100,000 years passed before anyone dug through the ruins. What would be left? Metal rusts, concrete crumbles, plastics break down in sunlight, forests reclaim cities, oceans rise and fall, continents shift shape. In many places, even the ground itself gets recycled through plate tectonics. The truth is, almost nothing survives that kind of timescale. As we look to the past, we are limited by what we can uncover. And that's where the real question lies. Could we have missed something? The records we rely on only tell part of the story, with vast gaps where evidence either doesn't survive or hasn't been found. So when archaeologists say there is no evidence for a society that existed 100,000 years ago, it doesn't necessarily mean it didn't exist. It could simply mean that the evidence is long gone or hidden, waiting to be uncovered in places we haven't yet looked. If we stop to think about it, this question is far more than just academic curiosity. It has deep implications for how we view ourselves today. Our civilization, as we understand it, is often seen as the peak of human development, an apex where technology, art and science converge in ways never before seen in history. But what if we are not the first civilization to reach these heights? And what if, long before us, a society thrived, reached the stars, and then disappeared, only to be buried by time and nature? Would this change how we see ourselves and our future? Could we be just the latest in a long line of civilizations that have risen and fallen throughout Earth's history? When archaeologists claim there is no evidence for an advanced society from such distant times, it doesn't necessarily mean that one never existed. It might simply mean that the evidence is lost, destroyed, or buried in places we haven't yet explored. The real challenge is not just the missing pieces, but the fact that our methods for uncovering the past are tailored for the last few thousand years, not for civilizations that existed 100 millennia ago. This question is essential because it forces us to rethink how we perceive ourselves and our place in the world. Modern civilization often feels like the apex of human achievement, the first time Earth has witnessed the vast scale of technology, art and science. But what if we are wrong? What if we are not the pinnacle, but merely the latest in a long cycle of rise and collapse. This unsettling possibility implies that we are not unique. Perhaps we are not even the first to dream of reaching the stars. If there was an advanced society before us, the next question must be, where did they go? Did they destroy themselves, bringing about their own collapse? Were they wiped out by something beyond their control, something that no one could have predicted or stopped? Or did they simply fade away, letting the planet reset itself until the next civilization, ours, emerged? The question, though historical in nature, isn't just about the past, it's about the future. Because if such a civilization existed before, it could happen again. And maybe, just maybe, we are not at the beginning of the story, but somewhere in the middle, with the chapters of human history far older than we've been led to believe. This discrepancy between what we think we know and what is truly possible starts with how far back we currently think civilization extends, and why the numbers we use to define it might be entirely wrong. When historians talk about civilization, they typically refer to organized societies with cities, written language, agriculture, and some form of government. By this definition, the earliest known civilizations are surprisingly recent. The Sumerians in Mesopotamia, for instance, date back only about 5,000 to 6,000 years. The ancient Egyptians came shortly after, and the Indus Valley civilization roughly aligns with this timeline as well. These are the first cultures that left behind written records, monumental architecture, and large-scale infrastructure that we can still study today. Before this, the historical record becomes fuzzy. What we do know, however, is that humans were already intelligent and creative, leaving behind tools, cave paintings, and burial sites, but without the large systems of governance, cities, or written language we associate with civilization today. Agriculture, for example, is believed to have started around 10,000 to 12,000 years ago in various parts of the world, a development that marked a major shift toward modern societies. This period, the span from the first cities to now, might seem vast, but it is tiny in comparison to how long modern humans have been on Earth. Homo sapiens, our species, has existed for at least 300,000 years, making the era of civilization, as we understand it, just a small fraction of our total existence. For over 95% of our history, humans lived without cities, without written records, and without any form of recorded history, or so we assume. The foundation of this assumption is the limited evidence we have uncovered and how far back that evidence currently reaches. But this narrow perspective relies heavily on what we have been able to find and what we consider significant. Many times what survives through history is entirely dependent on what is durable enough to endure over time. Stone tools, bones, and other physical remains can last tens of thousands of years, but everything else, wood, textiles, pottery, decays far faster. What if there was more to the story, hidden beyond our current understanding of what is or isn't possible? Could something from the distant past be waiting for us to uncover it? Something that doesn't fit the neatly drawn timelines we've constructed? That whole span from the first cities to now is tiny compared to how long modern humans have existed. Homo sapiens, our species, has been around for at least 300,000 years. This means that for over 95% of our existence, we lived without cities, without writing, and without recorded history. Or so we assume. This assumption rests on a simple, but ultimately fragile foundation. We believe civilization began recently, because that's as far back as the most obvious evidence stretches. However, evidence is fragile, and over time, much of what once existed has disappeared. The oldest surviving stone structures, like the temples of Göbekli Tepe in modern-day Turkey, are only around 11,000 years old, and even they were buried for thousands of years before being uncovered. We have no monumental architecture from 50,000 years ago, let alone 100,000, so we assume that nothing existed from that time. But absence of evidence is not the same as evidence of absence. If an advanced civilization rose and fell tens of thousands of years before the ones we know of, it's unlikely that its ruins would be sitting in plain sight, waiting to be discovered. Erosion, shifting vegetation, and the movement of land itself would bury or destroy most traces. The further back in time we go, the more likely it is that the landscape has completely changed. Coastlines have shifted, river courses have moved, and entire land masses have been submerged or uplifted. And there's another reason we might be missing evidence of an older civilization: our own bias. Archaeology, as a field, tends to focus its resources on sites that are already suspected to hold remains, often because of nearby discoveries, ancient texts, or local traditions. Nobody is digging deep beneath the seafloor, searching for ancient cities that may have existed 100,000 years ago, simply because mainstream history doesn't consider such a discovery likely. In science, expectations shape the search, and the search itself shapes what we find. Our current timeline is essentially a story built on the evidence that has survived long enough for us to find, and that has been located in places we've chosen to explore. It's a timeline that fits neatly into a few thousand years, but it may leave out entire chapters that stretch back far further than we currently imagine. If we allow ourselves to broaden that timeline, even just as a thought experiment, the possibilities become enormous and unsettling. What would Earth have looked like in the year 100,000 BCE? What was the climate like? What was the geography? And who were the people living at the time? If we could step into a time machine and dial it to 100,000 BCE, the first thing we would notice is that Earth would feel both familiar and alien. The continents would be roughly in the same places, but the coastlines would look entirely different. The land masses we know today would be submerged beneath the rising seas, and the outlines of the continents themselves might be distorted. We would be able to see vast stretches of land that are currently underwater, hidden beneath the waves that have since reclaimed them. What's now considered dry land could have been fertile plains, ripe for habitation. River systems that today seem unremarkable might have once been the lifeblood of early human settlements. The changes to Earth's landscape over the past 100,000 years have been staggering. Coastlines have shifted, but more than that, entire regions have been reshaped by the slow but relentless forces of nature. What seems fixed today, a mountain range, a river, even an ocean, might have been radically different back then. The sea levels were much lower during the last ice age, exposing huge expanses of land that we now consider lost forever. Those areas submerged by the rise in sea levels could have been home to ancient civilizations, long forgotten by time. Earth would feel both familiar and alien. During the last ice age, vast areas that are now submerged beneath the ocean would have been dry land because so much water was locked up in massive ice sheets. This was a colder period, when glaciers covered much of North America, northern Europe, and parts of Asia. The world's climate was harsh, but it wasn't uniformly frozen. The tropics still had warm regions, deserts still existed, and grassland stretched over areas that are now forests or farmland. The sea levels were far lower, exposing vast coastal plains. The English Channel, for example, was once dry land, connecting Britain to mainland Europe. A land bridge known as Beringia linked Siberia to Alaska, bridging Asia and the Americas. These extra land masses were habitable, though many have since been swallowed by rising seas. By 100,000 BCE, humans were already present. Anatomically modern Homo sapiens had been on Earth for at least 200,000 years by this point, sharing the planet with other hominins, such as Neanderthals in Europe and Denisovans in parts of Asia. There were no cities, at least none that we know of, but humans were already skilled hunters and foragers. They crafted tools from stone, bone and wood, used fire, and likely had languages complex enough to convey detailed information. The picture of these people, as purely primitive, comes from the artifacts we found: tools, shelters, and art made from durable materials. If they had built anything more advanced, such as structures from perishable materials like wood, textiles, or certain kinds of composites, those traces would have vanished long ago. We might be underestimating how much these early humans knew, simply because the evidence has disappeared. In 100,000 BCE, much of the Earth was sparsely populated by modern standards. Human populations were small and scattered, but that doesn't necessarily mean they couldn't have been more advanced than we think. A small, intelligent population, especially if concentrated in a fertile, stable region, could theoretically have developed advanced knowledge and techniques. Additionally, the planet's resources and landscapes were in a very different state than they are now. Rich deposits of minerals lay closer to the surface, untouched by the developments of modern civilization. Forests and ecosystems were pristine, offering materials and opportunities that no longer exist in the same form today. If a group of people during this time had both the intelligence and the right environmental conditions, it's not impossible that they could have developed in ways that left almost no recognizable trace. The Earth itself has undergone tremendous change since then, with shifting coastlines, rising seas, and the gradual destruction of once fertile land. The evidence of their existence might not just be hidden beneath layers of soil or water, but lost in the very fabric of time, buried and erased by the forces of nature. The evidence has disappeared. Now, when we look back at 100,000 BCE, we see a wild, uncharted world with scattered human groups, but we can't be sure there weren't pockets of something more, enclaves where people had knowledge, methods, or even technologies far beyond what we imagine for that time. The fact that we haven't found these traces yet may say more about our limitations than about the truth of the past. One key reason we assume early humans were simple and primitive is because of the story we've been told. This story has been shaped by the evidence we've uncovered. Archaeology, as a science, depends heavily on physical remains. Stone tools, bones, pottery, and cave art can survive for tens of thousands of years. But more fragile materials, such as wood, fabrics, and plant-based tools, vanish in a fraction of that time. This survival bias means that we mostly encounter the more durable, crude-looking parts of ancient life, things that have survived the ravages of time. As a result, we build our picture of the past from an incomplete set of evidence. When we imagine humans from 100,000 years ago, we often picture them wearing animal skins, living in rough shelters, and using basic stone tools. This image comes from the things we've unearthed. However, just because we've found these items doesn't necessarily mean that they were the limits of what these people were capable of. If early humans worked with advanced materials that degraded quickly, or developed forms of technology that didn't require massive stone monuments, much of that evidence would have been invisible to us. What if there were tools and structures that simply didn't survive because they were made of perishable materials or designed in ways that didn't leave permanent traces? Another reason we hold these assumptions about early humans is based on our own sense of progress. Modern humans tend to view intelligence as a straight upward climb. Every step forward feels like a permanent achievement, and we assume that earlier stages of humanity must have been less advanced. But history within recorded time shows that this isn't always true. Civilizations rise, master complex skills, and then collapse, often losing knowledge that can take centuries to rediscover. If that can happen within 1,000 years, imagine what could have been lost over the course of 100,000 years. Moreover, we tend to underestimate the mental abilities of our ancient ancestors due to a bias that associates modern with smarter. However, anatomically modern humans from 100,000 years ago had brains just as large and complex as ours. They had the capacity for abstract thought, planning, symbolic communication, and problem solving. They lived in environments that required constant adaptation and cooperation, skills that were, in some ways, even more demanding than what we face today. The narrative of early humans as primitive fits comfortably into the way we like to think about ourselves. It makes us feel like the pinnacle of history, the first to truly understand the world and shape it according to our will. This image comforts us because it places us at the top of a long chain of progress. But perhaps this view of our ancestors is skewed, influenced by the incomplete evidence we've uncovered and by our own desire to see ourselves as the crowning achievement of human development. If that can happen within 1,000 years, imagine what could have been lost over the course of 100,000 years. This view of humanity's progress may stem more from our need to feel special than from what truly happened. If we can let go of this assumption, a very different picture emerges, one in which early humans, or perhaps even another species entirely, could have reached levels of sophistication that we haven't yet imagined. They could have left behind almost nothing that we would recognise as proof. And herein lies the problem of missing evidence over such long time spans. When we talk about events that occurred 100,000 years ago, we are dealing with a period so vast that it is hard to fully comprehend in our everyday lives. A century feels long, 1,000 years feels like ancient history, but 100,000 years, that is an enormous time frame where almost nothing made by human hands can survive in recognisable form. Materials break down, even stone, the most durable of human tools, wears away under constant wind, rain, and temperature fluctuations. Metals corrode, wood rots, fabrics disintegrate, and even plastics, which we consider long-lasting, can crumble to powder. Under the right conditions, the soil shifts, plants grow and die, animals dig and burrow. Over long enough periods, every trace of something on the surface gets scattered, buried, or erased entirely. And that's only the beginning. Geology itself poses a significant challenge. The Earth's surface is constantly moving, though at a pace so slow that it's almost imperceptible in our lifetimes. Mountains rise, rivers change course, and coastlines are reshaped by the constant erosion of wind and water. Land that was once fertile and flat can become swallowed by deserts or flooded by rising seas. The slow grind of plate tectonics ensures that entire regions can be pushed up, dragged down, or recycled back into the mantle, rendering them unrecognisable after the passage of time. In many parts of the world, the ground you stand on today simply didn't exist in the same form 100,000 years ago, even if an advanced society had once built massive cities or complex infrastructure. Most of their remains would have been claimed by these relentless natural processes. The tallest skyscraper today would crumble into dust within a few thousand years if left untended. Over the course of 100,000 years, even the outline of a city could be gone, replaced by a forest, desert, or ocean. Moreover, we must remember that humans haven't been searching for such deep evidence for very long. Archaeology and geology are still relatively young sciences, and most of the focus has been on more recent, accessible layers of the past. To search that far back, we would need to dig deeper than most excavations ever reach, often in places that are difficult to explore, such as beneath massive ice sheets or deep on the ocean floor. The truth is, there may be traces of civilizations hidden beneath layers of earth, water, or ice that we simply haven't yet discovered, because the methods and the drive to look that deeply have only recently come into focus. The reality is simple. The absence of clear physical evidence from 100,000 years ago doesn't mean that nothing advanced existed. It simply means that time is an expert at erasing. And if there was once a society with knowledge, technology, or culture far beyond what we expect for that era, it's entirely possible that their traces are now nothing more than scattered particles, buried beyond our reach. To understand why evidence from 100,000 years ago is so rare, we must examine how Earth constantly reshapes itself. The planet is not a static museum where artifacts sit undisturbed forever. It is more like a living system that recycles its own surface, ensuring that almost nothing stays the same for long. Erosion is one of the most significant culprits in this process. Wind carries fine grains of sand that can slowly grind down even the hardest stone over centuries. Rainwater seeps into cracks, freezes and expands, breaking apart rock. Rivers carve deep valleys, washing away everything in their path. Coastlines retreat under the constant push of waves, swallowing land and everything once standing upon it. Over the course of 100,000 years, erosion can erase mountains. So a building, a road, or even an entire city wouldn't stand a chance. And then there's the slow but unstoppable movement of the planet's tectonic plates. Continents drift, oceans open and close. In some places, land is uplifted into mountains. In others, it sinks beneath the sea. Entire regions can be buried under layers of sediment or volcanic ash. In the most extreme cases, the Earth's crust itself can be dragged down into the mantle and melted, permanently destroying whatever was once there. Natural decay works on a smaller but equally relentless scale. Organic materials such as wood, leather, and plant fibers break down in a matter of years in most climates. Metals corrode when exposed to oxygen and moisture, eventually crumbling to nothing. Even stone carvings, if not carefully maintained, can lose their shape until they are indistinguishable from weathered lumps of rock. Adding to this is the cyclical nature of ice ages, where glaciers advance and retreat like slow-moving bulldozers. When ice moves, it grinds everything beneath it into rubble, scattering the remains far from their original locations. Rising seas during warmer periods then flood coastlines, hiding whatever once stood there under layers of water and sediment. Over the span of a human lifetime, these processes may seem invisible, but over 100,000 years, they are absolute. The surface of the Earth we see today is in many ways entirely new compared to what it was back then. Over the course of 100,000 years, erosion can erase mountains, so a building, a road, or even an entire city wouldn't stand a chance. If an advanced society did exist that far in the past, most of its physical remains would have been erased, not by a catastrophic event, but by the quiet, steady work of the planet itself. This idea of ancient civilizations existing long before humans is not just a topic for science fiction enthusiasts or conspiracy theorists. It has been seriously considered by scientists. In 2018, two researchers, Gavin Schmidt, a climate scientist from NASA, and Adam Frank, an astrophysicist from the University of Rochester, published a paper exploring what they called the Kaaruran hypothesis. The name was a playful reference to a reptilian race from the British science fiction series Doctor Who. But the question they posed was real. If an industrial civilization had existed on Earth millions of years before humans, how would we detect it today? Schmidt and Frank's focus was on the geological record. They pointed out that the survival of physical artifacts, buildings, machines, or even bones over millions of years is extremely unlikely. However, certain large-scale environmental changes might last far longer. For instance, modern civilization is leaving behind distinct signals in the form of unusual chemical traces in the atmosphere, soil, and oceans. These include synthetic chemicals, radioactive isotopes from nuclear activity, and sudden spikes in greenhouse gases. Even if no skyscraper or city survived the ages, these signals could still be detectable deep in the geological layers, millions of years from now. The Kaaruran hypothesis suggests that if a civilization existed 100,000 years ago, or even far earlier, the best way to detect it might not be by finding physical ruins, but by looking for subtle anomalies in ancient sediments or ice cores. These anomalies could include unexpected changes in carbon levels, strange isotopic patterns, or deposits of rare materials that do not occur naturally. Schmidt and Frank weren't claiming that such a civilization definitely existed, but rather that the geological record does not entirely rule it out. They argued that our ability to detect an ancient advanced society depends on the questions we choose to ask and the places we decide to search. If we don't expect to find such evidence, we probably won't recognize the clues, even if they are right in front of us. What makes their work so intriguing is how it reframes the entire debate. Rather than simply asking, "Where are the cities and machines?" it asks, "What long-lasting fingerprints would any civilization leave on a planet?" This shift in perspective forces us to think beyond the tangible remnants of stone monuments or metal tools and consider the lasting environmental traces a civilization might leave behind, traces that may remain hidden for millions of years. The best way to detect it might not be by finding physical ruins, but by looking for subtle anomalies in ancient sediments or ice cores. When you think about it this way, it becomes easier to see how something advanced could have risen, flourished, and vanished without leaving behind the kind of ruins we usually imagine. What signs might a truly ancient advanced society leave behind? If an advanced civilization had thrived on Earth 100,000 years ago, what would actually remain for us to find today? The answer depends on the kind of civilization it was and the materials it used. We often imagine towering skyscrapers, highways, and sprawling industrial complexes, symbols of modern civilization. But these images are shaped by our modern way of life. In reality, physical structures like these are the least likely traces to survive. Instead, the most durable evidence of such a civilization would likely be indirect, subtle fingerprints embedded in the environment rather than standing monuments. One possible trace could be unusual chemical signatures in the soil or rock layers from that time. If the society had engaged in large-scale metallurgy, mined rare minerals, or created synthetic compounds, some of those byproducts might remain locked in the sediments, detectable by scientists. Modern researchers have already found human-made chemicals in today's environment that are expected to persist for hundreds of thousands of years, such as certain plastics or fluorinated compounds. If a similar technology existed in ancient times, these chemicals could still be detectable deep within the geological layers. Another potential marker might be shifts in the carbon cycle. Industrial civilizations tend to alter their planet's atmosphere in significant ways. If ancient people burned large amounts of biomass or fossil fuels, it could have caused spikes in greenhouse gases like carbon dioxide or methane. These changes can sometimes leave measurable imprints in ice cores or ocean sediments, detectable even after vast spans of time. Additionally, mining scars, areas where valuable minerals or ores were extracted, might provide clues. Over thousands of years, erosion and vegetation might conceal these scars, but some large-scale disruptions to the bedrock could still be visible to geologists who know where to look. Radioactive isotopes might also be a sign of ancient industrial activity. If this civilization developed nuclear technology, traces of unusual isotopes could persist for hundreds of thousands of years. These would be rare and not naturally occurring in such concentrations without human intervention. Even ancient garbage dumps, if they were somehow fossilized, could hold valuable clues. In rare instances, layers of waste from past human settlements have survived for thousands of years. If conditions were ideal, these deposits could last even longer, preserving artifacts, chemical residues, or fragments of unusual materials. But here's the problem. Finding these traces requires knowing exactly where to look and digging deep enough to reach them. The most likely places to preserve such evidence would be locations that remained geologically stable for the past 100,000 years, areas that escaped flooding, glaciation, or heavy erosion. These places are rare, and without a reason to target them, we might never investigate the right spots. This means the signs of a truly ancient advanced society could be out there, tiny and hidden, but indistinguishable from natural anomalies, unless we actively search for them with this possibility in mind. When we think about uncovering the past, we often picture ruins, crumbling temples, half-buried statues, and broken pottery. But the truth is, those are the rare exceptions. Most of what humans create, even in our modern world, is incredibly temporary on a geological scale. A mere 10,000 years is enough to erase the majority of physical artifacts. A span of 100,000 years makes survival almost impossible. Take metals, for example. Iron rusts quickly when exposed to oxygen and moisture, breaking down into flakes and dust. Copper corrodes into a greenish powder. Aluminum, although resistant to corrosion, would eventually oxidize and fragment. Even gold, which doesn't tarnish easily, could be dispersed and buried by shifting soils and erosion. Stone, which we often think of as eternal, isn't immune either. Monuments like the Great Pyramids have lasted for thousands of years because they are massive, built in a dry climate, and maintained to some extent. But even stone erodes under constant exposure to wind, rain, ice, and plant roots. Over tens of thousands of years, carvings lose their detail, walls collapse, and entire structures crumble into rubble, which eventually becomes indistinguishable from natural rock formations. Organic materials are even more fragile. Wood rots quickly unless preserved in very dry or waterlogged conditions. Textiles, paper, and leather can vanish within a few centuries, or even less. Plastics, which we see as a modern environmental problem because of their persistence, would also eventually break down when exposed to sunlight, temperature changes, and chemical reactions. Even if an artifact somehow avoided natural decay, the forces of geology could still erase it. The slow, steady work of the planet's natural processes can make it nearly impossible for any remnants of past civilizations to survive. Earthquakes, landslides, floods, volcanic eruptions and glaciers can bury or destroy entire regions. Rising seas can submerge coastlines, leaving whatever was built there beneath layers of silt and sand. This is why so many ancient cultures we know about left behind only fragments, bits of pottery, the foundations of stone buildings, or a few tools. And these remnants come from civilizations that lived just a few thousand years ago, not 100,000. The further back in time you go, the smaller the odds that anything physical has survived in a form we can recognize. It's entirely possible that even if a large, complex society existed in the distant past, its cities, machines, and tools have all been erased. Without knowing exactly where to dig and what to look for, we might never even realize they were there at all. Archaeology is a powerful tool for piecing together the past, but it has its limits, especially when we try to reach as far back as 100,000 years. Most archaeological work focuses on periods where evidence is both accessible and abundant. That usually means the last few thousand years, where we have physical remains in relatively good condition, and in many cases, written records to guide us. Once we push past about 10,000 to 15,000 years, those advantages fade quickly. One of the biggest challenges is depth. Over long time scales, soil builds up. Rivers deposit sediment, and volcanic ash or wind-blown dust can bury landscapes under many meters of material. Sites from 100,000 years ago might be far beneath the layers we normally excavate. Digging that deep is expensive, time-consuming, and often impractical, especially without clear evidence that something important is down there. Another challenge is preservation bias. Archaeologists often target areas where artifacts are more likely to survive, such as caves, deserts, or regions with slow geological change. These locations are valuable for finding stone tools, bones, or cave paintings, but they don't represent the entire picture. If an ancient society existed in a region that has since been flooded, eroded, or covered by jungle, its remains are far less likely to be discovered. Funding and priorities also play a role. Research is often driven by specific questions, and the idea of an advanced civilization existing 100,000 years ago is not widely accepted in mainstream archaeology. Digging that deep is expensive, time-consuming, and often impractical, especially without clear evidence that something important is down there. This means fewer digs are designed to look for such evidence, and fewer resources are allocated to exploring possibilities outside the established timeline. Even if we do find something unusual, interpreting it becomes another obstacle. A single artifact out of place might be dismissed as a coincidence, contamination, or a misdated object. Without a broader context, such as multiple artifacts, settlement patterns, or supporting environmental data, it's hard to convince the scientific community that it represents something extraordinary. In short, archaeology is limited not just by what survives, but by where we look, how deep we're willing to go, and what we expect to find. If an advanced society existed 100,000 years ago, it may well be hidden in places we've never thought to search, or buried so deeply that we haven't yet reached it. Places where we might still find traces, deep underground, under ice, or beneath the ocean. If such a society did exist, the best chance of finding its remains isn't in the open fields or deserts we typically imagine. It would be in environments that have been shielded from the constant wear and reshaping of Earth's surface. These hidden environments might have quietly preserved traces while the rest of the planet's surface continued erasing them. One possibility lies deep underground. Natural caves, sealed chambers, or human-made tunnels could protect artifacts from erosion, weather, and plant growth. Even here, survival is not guaranteed, but conditions in stable, dry caves have preserved human remains and tools for tens of thousands of years. If an ancient society dug storage vaults or shelter systems into bedrock, some fragments of their civilization might still be waiting, buried under layers of sediment. Another promising location is beneath ice. Large parts of Greenland and Antarctica have been covered by ice sheets for hundreds of thousands of years. If land beneath that ice once held settlements before the ice advanced, those sites could be sealed away, untouched. However, accessing them would be nearly impossible without drilling through kilometers of frozen layers. While this presents an extreme challenge, theoretically, such places could hold perfectly preserved evidence from ancient civilizations. Perhaps the most intriguing possibility lies beneath the ocean. During the last ice age, sea levels were far lower, exposing vast coastal plains where humans could have lived and thrived. When the ice melted and the seas rose, these areas were flooded, turning them into continental shelves now hidden underwater. If a civilization once thrived in these submerged regions, it could be preserved beneath the ocean, hidden in plain sight. The submerged landscapes could be home to ancient river valleys, hills and plateaus that once supported life. If settlements existed there, they might be buried under layers of marine sediment, shielded from surface erosion. We know from modern archaeology that many of humanity's earliest known sites are close to water, rivers, lakes and coastlines. If the same was true for an ancient advanced society, then much of their world might now be underwater. The problem, however, is that underwater archaeology is expensive and technically difficult, especially in deep or sediment-heavy regions. As a result, huge stretches of submerged land remain unexplored. If we ever find undeniable evidence of a civilization from 100,000 years ago, it will likely come from one of these hidden zones, not because they were particularly special to that society, but because they are among the few places where time's erasing hand has been slowed enough to give us a chance. These submerged areas, hidden from the ravages of surface erosion, could hold key clues to an ancient civilization's existence. One of the most dramatic ways Earth reshapes itself over time is through changes in sea level. During the last ice age, so much water was locked up in massive glaciers that the oceans were more than 100 meters lower than they are today. This exposed huge stretches of land that are now completely underwater, places that would have been prime real estate for any human or human-like society living at the time. If we could drain the oceans and see the continental shelves as they were 100,000 years ago, we'd find vast plains, river valleys, and coastal areas that no longer exist on the surface. These regions would have offered rich resources, fresh water, fertile soil, and abundant fishing, making them natural hubs for settlement. If an advanced society had developed back then, It's easy to imagine them building along these coastlines, just as we do today. When the Ice Age ended and the climate warmed, the glaciers melted. Over thousands of years, the rising seas slowly swallowed those low-lying lands. Entire landscapes disappeared beneath the water, along with anything that had been built on them. And unlike land sites, which can sometimes be preserved under layers of sediment, these drowned worlds were often scoured by waves, currents, and storms before being buried. That makes them even harder to find today. The sheer scale of what's hidden is staggering. Some estimates suggest that more than 20 million square kilometres of land, about the size of North America, was lost to rising seas at the end of the Ice Age. Most of it has never been mapped in detail, making it an even greater challenge to uncover. The potential of this lost world is immense, but it remains concealed beneath the ocean's depths, waiting for the right combination of technology, time, and curiosity to unlock its secrets. What little underwater archaeology we've conducted has already revealed ancient tools and settlements from much more recent times, hinting at what could still be waiting deeper in the past. The problem, however, is access. Exploring these submerged areas is expensive, technically challenging, and often dangerous. It requires specialized equipment like sonar mapping, submersibles, and deep-sea drilling. And because mainstream history doesn't expect to find cities or advanced technology from 100,000 years ago, these areas are not a priority for exploration. It's entirely possible that, if a society existed back then, much of its world is now hidden beneath the waves, erased from view, yet preserved in fragments under layers of marine sediment. Until we make a serious effort to search these drowned coastlines, we may never know how much of our planet's deep history lies just out of sight in myth and legends. Throughout history, cultures around the world have passed down ancient stories about great cities, powerful peoples, and catastrophic floods that wiped them away. These stories are often dismissed as pure myth, invented to explain natural events or to teach moral lessons, but some researchers wonder if they might be faint echoes of real events, fragments of cultural memory passed down through countless generations. The most famous example is the story of Atlantis, written about by the Greek philosopher Plato. He described it as a great island civilization with advanced knowledge, which was destroyed in a single day and night by floods and earthquakes. Mainstream historians generally view Atlantis as an allegory, but its vivid details and sudden destruction have fueled speculation for centuries. Could it be a distorted memory of a much older society that vanished beneath the sea? Similar themes appear far beyond Greece. Indigenous peoples in Australia tell stories of coastal lands that were once dry but were later swallowed by the ocean. In South Asia, ancient Sanskrit texts speak of great kingdoms destroyed by floods. Native American traditions recount times when the earth was reshaped and entire peoples were lost. The biblical story of Noah's flood mirrors older Mesopotamian tales of a great deluge sent by the gods. It's important to note that oral traditions can survive for thousands of years, passed down from generation to generation. These stories might not be as fantastical as they seem. They could contain kernels of truth about real events that occurred long ago when rising seas swept away entire civilizations. Perhaps in some cases they represent the memories of lost societies, buried beneath the ocean, their remains hidden in the same places we are now beginning to explore. Oral traditions can survive for thousands of years. In some cases, researchers have linked Aboriginal stories to real geological events, such as the flooding of certain coastal areas after the last ice age more than 7,000 years ago. If memories can last that long, it's not impossible that fragments of much older events could survive, albeit in an altered form. Of course, myths change over time. Details are added, meanings shift, and the supernatural often replaces the practical. A real city destroyed by rising seas could, over generations, turn into a story of a golden kingdom sunk by divine punishment. But underneath the embellishment, there might still be a core of truth, a memory of a time when the world was different, and something remarkable was lost. If an advanced society had existed 100,000 years ago, and if some of its people survived whatever event caused its end, they could have passed on pieces of their story. Over thousands of years, those pieces might have blended with other tales, reshaped by each culture that retold them. Today, we might see them only as scattered myths, never realizing that they might all point to the same forgotten reality. From time to time, discoveries are made that don't seem to fit the accepted timeline of human history. These are often referred to as out-of-place artifacts. These are objects found in geological layers, archaeological sites, or contexts where they shouldn't logically exist. Most of these finds have conventional explanations once studied in detail, but a few continue to raise questions, fueling speculation about whether our history is incomplete. One well-known example is the Antikythera mechanism, a complex geared device found in a shipwreck off the coast of Greece, dating to around 2,000 years ago. It was clearly built in the ancient world, not 100,000 years ago, but its sophistication was far beyond what historians thought possible for that era. The mechanism reminds us that technology can appear earlier than expected, and it can be lost for centuries afterward. More controversial are artifacts claimed to be much older. Reports exist of metal spheres found in South African mines, allegedly in rock layers billions of years old. Most geologists believe these are natural formations, but their unusual symmetry has sparked debate. In Illinois in the 1940s, a lump of coal was reportedly broken open to reveal an iron pot inside, though no verified scientific record remains to confirm it. Similar stories exist of nails, chains, or other objects found embedded in stone, though most lack solid documentation or have been explained away as contamination from more recent times. Most of these finds have conventional explanations once studied in detail, but a few continue to raise questions, fueling speculation about whether our history is incomplete. There are also the famous London hammer, a tool encased in a rock concretion, and ancient-looking carvings or sculptures found in unexpected layers. In many cases, these artifacts turn out to be younger than initially claimed once tested, but the persistence of such stories reflects a deep curiosity. Could there be objects out there still undiscovered that truly date back far beyond our known history? The challenge with out-of-place artifacts is that even if one were genuine, proving it would be difficult. Establishing an object's true age and confirming it hasn't been moved or contaminated by later processes is extremely hard, especially if it's been found accidentally rather than in a controlled excavation. For now, no verified artifact points to an advanced society from 100,000 years ago, but these controversial finds keep the door open for possibility. They remind us that surprising technology can appear, vanish, and be rediscovered, and that the historical record may still have gaps we haven't even begun to fill. When we imagine an advanced society, our minds automatically picture something like our own world. Cities with skyscrapers, vehicles, computers, power grids, and factories. But this is a narrow view, shaped by the fact that our own civilization relies heavily on visible, durable infrastructure. If an advanced society had existed 100,000 years ago, it might have been advanced in ways that looked nothing like ours, and therefore left almost no recognizable trace. Technology doesn't have to mean electronics or steel. A civilization could reach a high level of sophistication using materials and methods that were entirely biodegradable. Imagine a society whose architecture was made from advanced composites based on plant fibers, or whose tools were made from high-strength organic materials that decayed completely within centuries. Without stone monuments or metal frameworks, such a culture could rise and fall without leaving behind anything we'd recognize as a ruin. Their energy systems could also have been very different from ours. We rely on fossil fuels, nuclear power, and large-scale electricity grids, all of which leave behind distinctive environmental marks. But what if they used forms of energy that were clean and left no geological footprint? Perhaps they tapped into geothermal sources, advanced solar technologies, or even biological systems we haven't yet rediscovered. Imagine a society whose architecture was made from advanced composites based on plant fibers, or whose tools were made from high-strength organic materials that decayed completely within centuries. It's also possible their advancement was more biological or intellectual than industrial. They might have mastered genetics, agriculture, or medicine at a level far beyond ours, focusing on improving themselves and their environment rather than building towering cities. Their technology could have been embedded into living systems, crops, forests, or even their own bodies, rather than separate machines. And their society might not have been large in scale. Our model of progress assumes growth and expansion, but an ancient civilization could have chosen stability over sprawl, keeping their numbers low and their footprint minimal. Such a culture could be highly advanced in knowledge and capability, yet nearly invisible in the archaeological record because they didn't build in ways we expect to find. If we only look for our own reflection in the past, modern-style industry, metals and monuments, we might miss the signs of a civilization that advanced along a completely different path. The more we imagine alternatives, the easier it becomes to see how something remarkable could have happened 100,000 years ago without leaving behind the kinds of clues we're trained to notice. Could they have used technology unlike anything we'd recognize today? When we search for evidence of a past civilization, we tend to look for objects and systems that match our own experience. Metal tools, ceramic vessels, stone buildings, and electrical devices. But what if an advanced society from 100,000 years ago used technology so different from ours that we wouldn't even realize it was technology at all? It's possible they developed materials that don't survive long periods in nature. For example, a highly advanced polymer made from organic compounds might have been stronger and more versatile than anything we have today, but also designed to fully biodegrade in a matter of decades. That would make it perfect for their needs, but nearly useless for archaeologists trying to find it now. The result? An entire technological base could vanish without a trace, leaving only natural-looking soil and sediment behind. They might also have relied on energy systems that leave no permanent marks. We burn fuels, split atoms, and build massive infrastructure to power our world. But an older civilization might have used subtle and localized sources of energy, harnessing geothermal heat directly, or converting sunlight into power through living plants engineered to store and release energy. These approaches could sustain a society for thousands of years while leaving almost no geological signature. Their communication systems might also have been invisible to us. These approaches could sustain a society for thousands of years while leaving almost no geological signature. We depend on devices, satellites, and physical infrastructure. But an ancient civilization might have used biological networks, direct neural interfaces, or some form of quantum-based communication that required no permanent structures. Even if remnants of their society survived, we might mistake them for natural anomalies, not realizing they were once part of a complex system. And what about transportation? Our vehicles need roads, ports, and airports, but theirs might have left no such footprint. Perhaps they travelled primarily by sea, in advanced organic vessels that decomposed naturally. Or perhaps they never needed to travel much at all, because their society was organised around self-sufficiency and minimal resource movement. If such a civilization existed, our current archaeological methods would be poorly suited to detect it. We're very good at identifying chipped stone tools, pottery fragments, and metal objects. But if their advancements didn't take these familiar forms, we might have walked right past the evidence without noticing. This raises a challenging possibility. The traces of a civilization from 100,000 years ago might already have been found, but misclassified as natural formations unexplained anomalies, or unimportant debris. Without expecting to see something radically different, we may never recognize it for what it truly was. The possibility exists that they didn't need metals, plastics, or even cities as we know them. Our definition of civilization is heavily influenced by our own way of living. We see metals, plastics, and large cities as essential markers of advancement because they are essential to our own advancement. But an advanced society 100,000 years ago might not have needed any of these things. In fact, they may have deliberately avoided them. Metals are rare in nature, and extracting them requires mining, smelting, and large amounts of energy. We treat these processes as unavoidable for modern life. However, another society could have developed entirely different solutions. They might have relied on advanced ceramics, engineered stone, or biological materials grown to meet precise needs. A civilization that mastered such materials would never need iron, steel, or aluminum. Without metals, their archaeological footprint would be far smaller and much harder to recognize. Plastics, too, might have been unnecessary. While we've created synthetic polymers from petroleum, an older civilization could have learned to produce similar or even superior materials from renewable organic sources. If these materials were designed to biodegrade completely after use, no trace would remain for us to find. A civilization that mastered such materials would never need iron, steel, or aluminum. From an environmental perspective, that would be far more sustainable. But from our perspective as archaeologists, it would look like they never existed at all. Cities, as we know them, dense permanent population centres, are not the only way to organise a society. A highly advanced culture could have lived in widely spread, self-sufficient communities. Instead of building stone monuments or concrete towers, they might have constructed lightweight, temporary dwellings adapted to seasonal movement or environmental change. If they lived in harmony with the landscape rather than altering it permanently, there would be little for future generations to uncover. It's also possible that their concept of infrastructure was entirely different. Instead of building physical networks of roads, bridges, and pipelines, they could have relied on living systems, rivers for transport, forests for resources, and naturally fertile areas for food. The knowledge required to manage such a system sustainably over centuries could represent a form of advancement equal to or greater than ours. But it wouldn't leave behind the same kinds of ruins we associate with progress. If we judge all past civilizations by the presence of metals, plastics, and monumental architecture, we risk overlooking those that advanced in ways we can't easily measure. The absence of these materials in the archaeological record might not mean there was no civilization. It only suggests that it was built on principles we've long since forgotten. If we consider the possibility that such an advanced civilization existed 100,000 years ago, the next question is obvious. What happened to them? For a civilization to vanish so completely that almost no trace remains, the end would have to be severe enough to erase their presence both physically and culturally. Several possibilities stand out, all of them plausible based on what we know about Earth's history. One is climate change. During the last ice age, the planet's climate shifted dramatically over relatively short geological periods. A society dependent on stable environmental conditions could have been devastated by sudden cooling or warming. A drop in global temperatures could have reduced food sources, shifted weather patterns, and forced mass migrations. Rising seas at the end of glacial periods would have flooded coastal regions, potentially wiping out the heartlands of such a civilization. Another possibility is an asteroid or comet impact. We know Earth has been struck many times in its past, sometimes with catastrophic results. The impact at Chicxulub 66 million years ago ended the reign of the dinosaurs, but smaller impacts in more recent history have caused regional devastation. A strike even a fraction of that size, 100,000 years ago, could have triggered wildfires, tsunamis, and atmospheric dust clouds that blocked sunlight for months or even years. Such an event could cause rapid collapse, especially for a civilization concentrated in one region. There's also the chance of massive volcanic activity. Supervolcano eruptions, like the one at Toba in Indonesia about 74,000 years ago, have the potential to cause global cooling and widespread famine. The Toba eruption is thought to have dramatically reduced human populations. If an advanced society had existed nearby, it could have been completely destroyed. Of course, self-destruction is another possibility. Advanced societies wield powerful tools, and if they are not used wisely, they can become instruments of collapse. Wars, environmental destruction, or over-exploitation of resources could have undermined their survival. If they depleted their environment beyond recovery, they might have faced a slow but inevitable decline, eventually fragmenting into smaller groups that reverted to simpler ways of life. It's also possible that their disappearance wasn't dramatic at all. A slow fade caused by migration, cultural blending, or gradual technological abandonment could have erased their identity over generations. Survivors might have integrated into other populations, their knowledge lost as it became less relevant in a changing world. Whatever the cause, the result would be the same. A once advanced civilization reduced to scattered people living in simpler ways, with their history forgotten. Over 100,000 years, even the memory of their existence could vanish, leaving us to wonder if they were ever there at all. When we talk about a gap of 100,000 years, we're dealing with a span of time so large that it's almost beyond human comprehension. Our oldest surviving written records go back only about 5,000 years. Beyond that, we rely on physical remains, which grow increasingly rare and fragmentary the further back we go. 100 millennia isn't just 20 times longer than recorded history. It's long enough for nature to dismantle almost everything we build and for memory itself to completely disappear. Think about the way stories and details change in just a few generations. 100 millennia isn't just 20 times longer than recorded history. It's long enough for nature to dismantle almost everything we build and for memory itself to completely disappear. A single historical event, retold by great-grandparents to their great-grandchildren, can become distorted or forgotten entirely in less than 200 years. Without writing to preserve it, an entire civilization's history could vanish from living memory in a matter of centuries. Multiply that by 1,000, and even the faintest cultural echo could be lost. Physically, the odds are no better. Earth's surface is dynamic. Erosion, landslides, earthquakes and floods constantly reshape it. In just a few thousand years, forests can reclaim cities, rivers can change course, and deserts can swallow entire regions. In 100,000 years, multiple ice ages can come and go. Coastlines can move hundreds of kilometers, and tectonic shifts can raise or lower entire landscapes. Even the most durable ruins would either be buried beyond easy reach or worn down until they are indistinguishable from natural formations. There's also the problem of human turnover. If survivors of an ancient advanced society were scattered or reduced to small populations, their descendants might have lived in simpler ways for thousands of years afterward. Over that much time, their origins could become nothing more than legend. And even that legend might vanish if survival took precedence over storytelling. The time gap problem isn't just about the destruction of artifacts, it's about the erasure of context. Even if we found a surviving object from such a society, we might not recognize its significance without the surrounding evidence. Other artifacts, structures, or environmental clues that could explain how it was made and used. An isolated discovery might be dismissed as a curiosity or misinterpreted entirely. In other words, 100,000 years is enough time not just to lose the details, but to lose the very idea that something ever existed. And that's why, if such a society did live and die in that vast stretch of prehistory, we might never be certain they were real. One of the most sobering lessons from history is how fragile complex societies can be. Even in our modern world, with global communication and advanced technology, we can see how quickly systems begin to fail when disaster strikes. Now imagine an ancient advanced society, perhaps concentrated in a limited area, facing a sudden catastrophe powerful enough to wipe out its population centres and disrupt its ability to sustain itself. It wouldn't take a chain of disasters, just one severe enough to break the foundation. A massive volcanic eruption, for instance, could blanket the skies with ash, cutting off sunlight for months or years. Crops would fail, temperatures would plummet, and food shortages would follow. If the majority of the population relied on centralized agriculture or trade networks, those systems could collapse almost overnight. An asteroid impact could be even more devastating. A large enough strike would release energy equivalent to millions of nuclear bombs, triggering tsunamis, wildfires, and shockwaves that flatten everything for hundreds of kilometers. Even those far from the impact zone would suffer as dust and debris filled the atmosphere, disrupting weather patterns and creating years of famine. War could also be a factor, not the kind of conflict we see between nations today, but a total breakdown of order in which cities are destroyed and infrastructure is lost. If the society depended on a delicate balance of cooperation and resource management, a rapid descent into chaos could undo centuries of progress in a short time. And then there's disease. In a connected, densely populated civilization, an epidemic could spread with shocking speed. Without a cure or immunity, it could decimate the population in a matter of months. If enough people died, specialized skills and knowledge could vanish with them, leaving survivors unable to maintain the technologies their ancestors built. Once the core systems of survival, food, water, shelter and security, break down, the focus shifts from innovation to basic existence. Within a few generations, the descendants of survivors might live in entirely different ways, with no practical use for the technologies their ancestors once relied on. Tools could be abandoned, buildings left to crumble, and the stories of how things used to be could fade into myth. From that point, nature would take over. Forests would grow through former streets, rivers would flood abandoned areas, and weather would wear away the ruins. Within a few thousand years, the visible traces could be nearly gone. After 100,000 years, there might be nothing recognizable at all, just the memory of a world erased. Could we still carry their DNA? If an advanced society lived on Earth 100,000 years ago, and if its people were human or closely related to us, then even if all their physical creations were lost, part of their legacy might still survive in our own bodies. DNA is one of the most durable records nature provides, and unlike cities or tools, it can be passed from generation to generation, surviving even when every other trace of a civilization is gone. We already know that our modern genetic makeup carries fragments from other ancient humans. Studies of modern populations show that people outside Africa have about 1 to 2% Neanderthal DNA, and some groups in Asia and Oceania carry small amounts of Denisovan DNA. These are the genetic echoes of encounters between our ancestors and other hominin species tens of thousands of years ago. If an advanced society existed 100,000 years ago, its people could have been part of Homo sapiens, another human species, or a blend of both. If any of them survived the collapse and interbred with other populations, their genes could still be with us today, scattered in small fragments across billions of people. We might already carry traces of their biology without realizing it. The difficulty lies in interpretation. Genetics can tell us that different human groups met and mixed, but it can't reveal whether those groups had cities, technology, or advanced knowledge. A DNA sample might prove a population existed, but not what that population achieved. We could find evidence of an unknown group from that period and still have no idea that they were the inheritors of a lost civilization. There's also the possibility that their genetic legacy has been diluted beyond recognition. Over tens of thousands of years, DNA from a small group can be blended into much larger populations until only tiny fragments remain. Fragments that are difficult to distinguish from random genetic variation. Without knowing exactly what to look for, identifying such an origin would be almost impossible. Still, the genetic record is a potential bridge to a past that has otherwise been erased. If scientists discover evidence of a mysterious ancient population in our DNA, it could prompt entirely new questions about who they were, how they lived, and whether they left behind more than just a biological trace. In that sense, our own bodies might be the last living connection to a forgotten world. Genetics can tell us that different human groups met and mixed, but it can't reveal whether those groups had cities, technology, or advanced knowledge. If we found proof today, if undeniable proof surfaced that an advanced society existed 100,000 years ago, the impact on our understanding of history would be enormous. It wouldn't just be another archaeological discovery. It would rewrite the timeline of human civilization from the ground up. First, it would challenge the core assumption that technological advancement is a recent achievement. We currently believe that complex societies, agriculture, and large-scale architecture began only within the last 10,000 years. Finding evidence of a much older advanced culture would prove that human or human-like intelligence reached those heights far earlier and possibly more than once. It would also force historians and scientists to reconsider how knowledge is preserved and lost. We like to think of progress as linear, but such a discovery would be a clear example of a civilization rising, thriving, and then disappearing so completely that it took 100,000 years for another to reach a similar level. That realization could change how we think about the resilience or fragility of our own modern world. In anthropology, it would open the door to new debates about human evolution. If the people of that society were Homo sapiens, it would mean our species achieved high technology much earlier than we believed. If they were another kind of hominin, like Neanderthals or an unknown branch, it would prove that intelligence and complex culture are not unique to us. The ripple effects would go beyond science. Religions, cultural histories, and national narratives would be challenged by the idea that we are not the first civilization, and that our distant predecessors may have been as advanced or even more advanced than we are. The public fascination with lost worlds, already strong with stories like Atlantis, would surge into serious academic study. Politically, such a find could spark competition over who controls the discovery and its interpretation. A single artifact, especially if it contained technology or materials we don't understand, could become the focus of intense global interest. Some might see it as a key to unlocking new knowledge, while others might view it as a threat to established power structures. In the end, proof of an advanced society from 100,000 years ago would shift the way humanity sees itself. We would no longer be the only civilization in our planet's history, just the latest in a line whose earlier chapters have been mostly erased. It would be both humbling and inspiring, a reminder that greatness has risen before, and that nothing guarantees it will last forever. This idea challenges the way we see our place in time. We like to think of ourselves as the centre of history, the culmination of a long and inevitable journey from simple beginnings to the complexity of the modern world. But the idea that an advanced society could have existed 100,000 years ago disrupts that narrative completely. It suggests that history isn't a straight climb upward, but a series of peaks and valleys, with civilizations rising and falling, leaving little behind. If we accept that possibility, we have to confront a humbling thought. We may not be unique, and we may not be permanent. Our technology, culture, and achievements might not be the first of their kind, and they may not last forever. Just as we know little about the potential civilizations that came before, future societies could know little about us, perhaps nothing at all. It also forces us to reconsider our assumptions about progress. We often see it as something that builds continuously over time, each generation adding to the work of the last. But if the same level of advancement has been reached before and then lost, progress may be less about inevitability and more about opportunity, a fragile combination of conditions that can vanish when the balance is broken. There's also the matter of perspective. We measure our history in thousands of years, but the Earth is billions of years old. Even the time humans have existed is a tiny fraction of the planet's lifespan. That means there's an enormous amount of room in the past for things to have happened without leaving an obvious trace for us to find. In that context, our modern world is not the final stage of civilization, but just a brief chapter in an ongoing story. This perspective can be unsettling, but it can also be liberating. If others have come before us, it means we're part of a much deeper legacy of intelligence and creativity on this planet. It suggests that the capacity for building complex societies isn't unique to one place, one time, or even one species. It might be something the Earth itself fosters again and again. Ultimately, the possibility of an ancient advanced civilization doesn't just change the way we see the past. A fragile combination of conditions that can vanish when the balance is broken. It changes the way we see ourselves now and the way we imagine the future. The difference between no evidence and evidence we haven't found yet. When scientists say there's no evidence for an advanced society 100,000 years ago, it's easy to hear that as a definitive conclusion, as if it's been proven that none existed. But in reality, no evidence often means something more modest. We haven't found any yet. That's an important distinction because finding something depends on both the survival of the evidence and knowing where and how to look for it. Imagine you're searching a vast forest for a single coin dropped centuries ago. The fact that you haven't found it yet doesn't mean it isn't there. It could be buried under leaves, lodged in a tree's roots, or sitting at the bottom of a stream. The same applies to archaeology on a 100,000-year scale. The Earth is enormous, much of it is inaccessible, and most of it has never been systematically searched for traces of civilizations from that far back. Even in well-studied regions, the focus is usually on more recent layers of history, where the chances of finding artifacts are higher. Excavating down to layers from 100,000 years ago is expensive, technically challenging, and often requires disturbing large areas of land. Underwater and underground exploration, where older evidence might be better preserved, is even more difficult and costly. There's also the problem of recognition. If we found a fragment of a material or device unlike anything we've seen before, we might not even realise it's artificial. Without a clear context, other related finds or signs of deliberate design, it could be dismissed as a natural formation or a meaningless anomaly. Many potential clues could already be sitting in storage or museum collections, unrecognised for what they are. This is why the absence of evidence is not proof that something never existed. It only tells us that nothing has yet been found that meets the criteria we're looking for. But those criteria are shaped by our expectations. If an ancient society had technology, architecture, or materials completely different from ours, we might be missing it simply because we aren't looking for the right things. In the end, no evidence may say more about our current limitations than about the truth of the past. Until we've searched more widely, more deeply, and with a broader sense of what might count as a clue, the possibility of something remarkable hiding in Earth's deep history remains open. Why imagining this deep past matters for the future. Whether or not an advanced society truly existed 100,000 years ago, exploring the idea forces us to step outside the narrow window of history we usually focus on. It reminds us that our species and the Earth itself have been around far longer than our written records, and that most of what has happened in that vast stretch of time is still unknown. The world we live in today is just one moment in an unimaginably long story, and we may be far from the first to write a chapter in it. Thinking about this possibility isn't just an exercise in curiosity, it's a way to reframe how we see ourselves. We tend to believe our civilization is permanent, that our progress will continue indefinitely. But if others may have risen and fallen before us, then we have to acknowledge that nothing is guaranteed. Knowledge can be lost, achievements can vanish, even entire cultures can fade from memory, leaving behind nothing but mystery. This perspective can be sobering, but it can also be motivating. If our time in the sun is temporary, we have an opportunity and a responsibility to decide what legacy we leave behind. Will we build a future that can endure, or will our own story become another forgotten layer, waiting for some distant descendants to wonder if we ever existed at all? It also broadens our sense of connection. If advanced societies have come and gone before, then we are part of a much older pattern, not a lone spark of intelligence in the dark, but one in a series of lights that have flared and dimmed across deep time. We may never know the names, faces, or languages of those who might have walked this path before us, but imagining their existence makes our own place in history feel both humbler and more significant. In the end, the question, what if Earth had an advanced society 100,000 years ago, is less about proving it happened and more about being open to the possibility. It's about remembering that history is not set in stone. It's pieced together from fragments, and there is far more missing than there is known. The truth may be stranger, deeper, and more surprising than we've ever allowed ourselves to believe. And perhaps one day, a discovery will be made that changes everything. Not just our understanding of the past, but our vision of what's possible for the future. If advanced societies have come and gone before, then we are part of a much older pattern. Not a lone spark of intelligence in the dark, but one in a series of lights that have flared and dimmed across deep time.